Good morning. We are starting the session Gentrack 4.1, and the first paper is presented by George Wiener, and the title is Identifying the Origin of Finger Vein Samples Using Texture Descriptors. Please, George.
Okay, hello everyone. My name is Georg Wimmer. I'm presenting the paper of two other authors from my university because I'm the only one here at the conference. And yeah, first the outline. We start with the introduction. Then we introduce the databases that we use. Then we present the used texture descriptors. Then we present the results, and finally the conclusion. The motivation first, the authenticity and integrity of the acquired finger vein image, which just plays a significant role in the overall security of a finger vein biometric system. If a finger vein sample image cannot be attributed to the sensor of the recognition system, then this would raise an alarm and stop an eventual authentication process. Yeah, and we have two aims. The first one is to secure a finger vein recognition system against insertion attacks. We see here an example of an insertion attack in the figure. And the second aim is we want to enable selective device processing of the image data if it's coming from different sensors. In our case, it will be different image databases. In previous work, in general, the sensor fingerprint was studied using methods based on the photo response non-uniformity, also called the PRNU. Mostly they use correlation-based methods for that. In this work, we have another approach, and we use texture descriptors to identify the origin of the finger vein image samples. In this work, we use 8 well-known public accessible finger vein databases. They are all acquired with different sensing devices. We can here see the 8 databases. And yeah. And our experiments, we apply them to the original datasets, but also to datasets consisting of region of interest extracted from the original data. And our database that we use for the experiments consists of 120 images per dataset, so this results in 960 images in total. And if you now have an evaluation image, we want to find out from which database it comes from, so which sensor is used or which database. Here we see some example of the properties of the finger vein images from the different databases. In the top row, we can see the luminance distribution of the original images and the ROE samples. On the left side, we see the original images, and we can see that the luminance is quite different for the different databases. This not so much applies for the ROE images. In the bottom row, we see the variance distributions of the samples, once again on the left for the original samples and on the right for the ROE samples. Here we can observe the same, but to a lesser degree. Okay. And so the original samples can be easily discriminated. Besides the difference in size, which of course can be adjusted by an attacker, the sample images can be distinguished by the extent and luminance of the background. Here we see two extreme different samples, two images from two different databases. We can see that they have totally different luminance distributions. Yeah. Then next we present the generation of the region of interest. So basically, in short, it's first the finger is segmented, and then it's aligned horizontally in the image, so it's fitted, and then we crop an image batch that is centered at the center of mass of the segmented image. And here on the right side, we can see 3 examples. Then next we want to present the different texture descriptors. So to discriminate between the sensors, which means also between the 8 databases, we apply a number of methods, and these methods include frequency-based methods, wavelength-based methods, and spatial-based methods. The first method is the Fourier ring filter. This method applies 15 bandpass filters to the image, and so it splits the image in 15 different frequency domains, each one a band, and then the feature vector is computed by concatenating the means and the standard deviations of each band. The next 2 features are features based on local binary patterns. And the first one is more or less the standard local pattern approach, and a histogram is built over the resulting local binary patterns. The next one is the same, but we use a uniform local binary pattern. So local binary pattern, if you know, the feature is just a sequence of zeros and ones with length 8. The feature, and for the uniform binary pattern, a pattern is called a uniform binary pattern if it contains at most 2 1 0 or 0 1 transitions. And once again, we build a histogram about the uniform local binary patterns. Then the image histogram, that's a very simple feature. We just generate a histogram over the pixel values of an image, basically. So it's the luminance distribution. Then we have 3 wavelet-based features. For this, we just use the discrete wavelet transform with 3 decomposition levels, and this builds subbands of the images. And for the first wavelet-based features, we extract the mean and the variance of each subband. For the second feature, we extract only the variance for each subband, and for the last one, we extract the entropy of each subband. Then the next one is the local entropy method. For this method, the image is sliced into 16 tiles, and the entropy is computed from each tile. And then we just build a histogram over the entropies, which generates the feature vector. And we have to mention that all the mentioned methods are designed in a way so that they're invariant to the image size. So for the classification, we apply a support vector machine, and the data is randomly split into training and evaluation, with 67% for training and 33% for evaluation. This is repeated 4 times. And we compute 2 different performance measures. For the first one, we use the receiver operating characteristic curve, or ROC curve. This curve plots the true positive rate against the false positive rate. But since we have 8 class classification and not a binary classification case, we have to adapt this, and so we use the average false positive rate and the average true positive rate. And here we have the example how the false positive rate is computed. That means C is the class, so the database, basically, and we sum all false positives for one class, sum over all classes, divided by the sum over C over all false positives, plus the sum of all true negatives for each class. Then the next curve is the precision recall curve, and this curve shows the trade-off between precision and recall. And once again, we have the same approach because we have the class classification, not a binary classification. Here is the formula. And as performance measures, we have 2. We just calculate the area under the curve for the precision recall curve and also for the ROC curve. Then next, we also want to investigate if image enhancement techniques helps for sensor identification, and so we apply Wiener filter and Klarheit. we call this approach as enhancement, but we also apply no enhancement so that we can compare enhancement versus no enhancement. Yeah, here we can see the results. The results are computed for the original samples as well as for the ROE image samples, for both with enhancement or without enhancement. When we compare the results, we can see that the frequency-based method, the Fourier ring filters, and the 3-wavelet-based methods achieve the best performance. The performance of these features is better than the spatial-based methods, the rest. And yeah, and enhancement mostly has a positive effect, but sometimes it also deteriorates the results. And the best results were achieved with the wavelet feature that extracts the mean and the variance of the step bands. Here the results are always close to 1, which would be the perfect result. And yeah. Here we compare our results to previous methods. These methods are based with 2 here based on the PR and U, and use they are both correlation-based methods, and compare it to our best feature, that was the wavelet feature with the mean and the variance. We can see that for the best result is achieved using the proposed wavelet feature for the original samples. Here the results are better than for the comparison methods. For the ROE images, the pair and group-based methods performed better. So in this research, we investigated and observed the following points. First, the texture descriptors are well suited for finger vein sensor model identification in case of finger vein images. Then the texture descriptors were applied to the regional images as well as to the more challenging finger vein region of interest data. And like expected, the methods perform better on the original data than the ROE data because it's easier. And the enhancement techniques, they mostly improved results, but not everywhere, so no clear improvements. Yeah. And the frequency-based and the wavelet-based descriptors, a wavelet is also kind of frequency because it splits the image in frequency bands, but also with orientation information, performed the best, are much better than the spatial domain techniques. And the best results was achieved using the wavelet technique, extracting the mean and the variance. So the good results suggest that the texture-based methods are well suited for this task, sometimes even better than the PR and U-based methods. And it would also be interesting if you use both methods, but that is something for future research that's planned. So thank you for your attention. Are there any questions?
Thank you. Thank you so much. Are there any questions?
I'd like to add something to that. I don't know whether it works now. Because also the
Can you come here?
Good morning, everybody. Good morning, everybody. Okay, I wanted to ask to Georg, because yesterday he also had a very interesting talk about images of trunks. What is not clear to me in the images of the fingerprint is what the data exactly consists of. So it's pixel-wise data on the wavelength, or what is it?
No, it's photos that are taken with near-infrared light.
So the reflection of the frequency is coming back, or?
Yeah, it's basically if you use the infrared light, then it highlights the finger vein structure, and this finger vein structure can be used for identification.
Mm-hmm. So what's the dimension of the data we are talking about? Any idea?
That depends also on the database, but the original images approximately maybe, but it's really different, maybe 400 times 800 or something.
Okay.
But it depends really on the database. Mostly more, I think, but I'm not sure now.
Okay.
And the readout is much smaller than
Yeah, I get the picture.
Yeah.
Thanks.
Okay. Did you consider if your technique is overestimating the samples?
Like how?
Since you reach a very high precision.
Yep.
Did you consider the possibility that you overestimate the samples?
Yeah, I don't. So the experiments were applied by two other people,
Okay.
and so I can't really answer
Okay.
that because I don't have the big insight about how the experiments.
Okay. Thank you. Okay. Well.
Okay, thanks.
Are there any other
Thanks.
presenters?
Non lo so.
Is someone present for paper a complex adaptive system approach for anticipating technology diffusion, income inequality, and economic recovery?
No?
So, if this guy, none of the presenter is here, I would like to give the floor to Yoki. That please present yourself because it's a missing paper yesterday. So we will lost this presenter now.
Yes. Hello. Okay. Thank you to allow me present my paper. So I'm very sorry for this inconvenience yesterday, but today I'm here. I'm going to share my presentation.
You know how to do it? We cannot see your screen.
I'm trying.
Oh, there is a button where you the bar with the red phone.
Yeah, the search one.
Sorry.
Search icon 1, 2, 3. Now I share.
Is the third? Is the third from the left?
From the
With an arrow.
left.
Can you see it in the bar above you?
Yes, I share it.
Okay.
But couldn't find my.
Okay, good. We see your screen.
Now you see my presentation?
Not yet.
No?
Not yet, but it depends what you share. Probably it's better if you share the whole screen. Stop the sharing and repeat the process.
Okay.
Oh, okay.
And repeat the process sharing the whole screen.
Okay. Oh.
Open your presentation. Okay. Okay, we see it. Good.
You didn't see it?
Yes, yes.
We-
Not now.
Not now. We were able to see it, but not now.
Oh my God.
No, no, leave.
Okay,
Okay.
okay, good, good.
Go now.
Go in presentation.
I can make it big on, is okay, like this?
Okay.
Okay, good, good, good. Proceed.
All right. Thank you. Okay, Yoki Kar from Daegu Catholic University in South Korea. I'm studying in computer software engineering. And then I'm going to present you guys my presentation about the implementation of Fourier application to real-world service based on adaptive big data management system for autonomous driving. I will introduce the statement of the problems, objective of the study, real-world backgrounds, data flow and control of autonomous vehicles, and some related literature. Number 3, the implementation of autonomous driving to real world, the different case of UML diagram, implementation, system architecture, deep learning process model, autonomous driving based in big data, and discussion conclusion at the end. So the background study like talk about autonomous vehicle is a currently hot topic. So the technology that provide access to a high level autonomous is very critical for the future automotive deployment. So with the evolution of the IoT, the car can see, the car can hear, the car can even predict the future. So the vehicles are becoming a big moving machines connected to the internet. So the car cannot only, to drive the people, but entertain people. It means that the car allows people to pay the bill, to make a call, to shop, and then to save the life during emergency. And this is gonna be the object of this topic. And connecting the car with the data, it is very, very important. So as I said, for saving the life during emergency, so we have cooperative automation research mobility application called Karma. So that platform aims to improve the transportation efficiency and safety with automated driving technology, which allow the groups of vehicles to travel very closely and safely at high speed using vehicle-to-vehicle V2x communication to control each vehicle's movement in union. So the rapid development of the communication technology and the need of cater to the aging population in developed countries as potentially the made autonomous driving a necessity. So the autonomous driving need to be secure for saving lives. That's why in our subject, we are trying to develop a system to connect the vehicle to technology, which is an indispensable part of working autonomous driving using a deep learning algorithm based on big data to propose a solution in this area. So some proposal method present a master connectivity in order to provide vehicle to everything function for fully autonomous driving, and big data service are changing the way people live, people drive. So it proposed also the design, analysis, design, and implementation by expanding the Fourier software stack to enable embedded computer function and based on high performance GPU from the functional safety perspective. Also, we focused on the application of Fourier to develop autonomous vehicle by converting window-based source to the robot operating system-based source when starting point and the point are specific of a variable. The SWOT analysis of implementation of autonomous driving to real-world service, AIDRWS. So the strange part of this study is about the high precision security control and connecting several intelligent vehicles with each other, and also detecting problems with the customer's car in real times. And the opportunity part will be like a development system of connected vehicle technology using deep learning algorithms based on big data and high technology to reduce a crash. Some weakness part is about the limitation that no guarantee the passenger during different complicated event. Just in this world, in this study, so because we little bit focus on the analysis, design, architecture instead of the full real implementation. But this object gonna be the future. It's gonna be the object of this point is gonna be the object of our future work. The straight part likes innovation, technology, ability, and skill to passenger to understand. The vehicle connected via a network work the same as IoT device and require a central management system to analyze and process the data generated. We have a convert window based source to robot operating system based on source for the simplest integrations, visions, sensor-based object recognitions, vehicle control based on external actuators, and the implementation of the completed route sequence. IoT device and the requirements require a central management system to analyze, and also the cloud platform implementation for autonomous cloud data is collected, the later image and the sensor, and so on. Oh, sorry, yes. So the real world we have we talk about the 6 level of autonomous vehicles. So from the level 1 to level 3, it is a human supervision in the first figure, and from the level 3 to level 5, it is a machine supervisor. And then in the level 0, no automation. Level 1, driver assistance. So the vehicle assists the driver with the other longitudinals. And though the level 2 is partial automations. This is the human supervisions. And the level 3 is a conditional automations. Level 4, high automation, and level 5 is a full automation of machine supervision. So all driving tasks are handled by the vehicles in all conditions. The advanced driving assistance system called ADAS are progressively demonstrating the reality of the vehicle taking over control from driver and playing the crucial role of preparing regulator, customer, and cooperations for the possibility that lay ahead. So we have automotive company can no longer be expert in just mechanical or, like, let's say, electrical engineering, but they need to be expert in the artificial intelligence, software development, big data analysis, machine learning. So the automotive industry need to collaborate across automotive suppliers, technology developer, or government to really understand and propose a solution right. So let's talk about the Fourier. So Fourier is like an open source software based in the robot operating system. In the robot operating system, all the message of topics are logged and timestamped to a bag file called the ROSBUG. So this can be used for replay of the message with the 3D visualizations tool for robot operating system. In robotic, it's often difficult to analyze the interactions with the multiple sensors at once. And this tool enables efficient analysis and debugging debugging of system. Yeah. In this figure, the first one is show the basic control and the data flow for autonomous vehicles. So the sensor records environmental information that serves as input data for the artificial intelligence core. So 3D maps are becoming commonplace for self-driving. AutoWare is based on robot operating systems, and in the robot operating system, the software is abstracted as the node and topics. The node represent individual component module, whereas the topics mediate input and output between node and as illustrated in the second figure. And they exchange each other. The camera driver nodes send the message to the image topic, and the message in the topic are received by the traffic light recognition and pedestrian detections node. So the topic are managed using first in, first out queue when access the multiple nodes simultaneously. At the same time, the robot operating system nodes can launch several threads implicitly. Data flow models in the self-driving car. So the detection function is implemented by the camera of the roofs, long distance radar, short, medium range, and then including the bright, ultrasonic, and the others. So it's just to collect the data in the real time and enter it as the input to the analysis module. So the analysis module, the analysis function use both locals and the local data and the big data in the cloud to analyze the resulting data. The next is implementation of autonomous driving.
3 minutes left, Yoki.
Yes?
3 minutes left.
Okay. So, okay, I talk quickly about the use case diagram. It operates here in the driver priority mode. And then to allow the embedded for the priority to connect to the vehicle controller area network. The next is a class diagram to analyze system from the robot operating system driving AutoWare, consulting the center, receive the service, providing the various additional perception. The next is the sequence diagram. So it shows here the labeling of the on sensor connected to the autonomous driving controller area network, allow the PC to be used, the embedded. The next is environment parameter of the implementations. And then this part I try to explain in the system real-time car work as follows: to receive the information and then the surrounding in great detail, identifying range, speed, and distance using camera and LiDAR, communicate with each other and share the information, connected the car technology. So it's proposed in the real time. So when the sensor installed in the vehicle recognize the dangerous situation, so the embedded device detects and judges the danger like before 5 or 10 seconds in advance, and they acquire various dangerous situation. Data is sent to the cloud, so we can say server, to retraining with the data. Over time, the learning model's performance gets better and more efficiency. So the system cloud in the real time remotely sees the problem with the customer car and immediately inform them through the vehicles. And also the object detection is used to detect the object in an image for video stream, individual frame, and also implementation of the ROS, transfer communications, each other. And then to conclude, the autonomous driving using deep learning labeling will change our future more conveniently. In this paper, learning models were designed and practice system was developed to improve the learner's data analysis thinking ability. The cloud platform implement the autonomous cloud database, collect the data, LiDAR image and sensor, and also from the ROS. Big data for autonomous vehicle is what help and makes use of sensor. As a big data accumulates, it is difficult to determine the location and type of the data present. Therefore, it is important to optimize the data management, and this will be the object of our future work. Here is the reference, and thank you guys for your attention.
Thank you for the presentation. Are there any comments, questions from the audience? Did you what type of experimental results did you collect? Have you made simulations, real simulation, or?
Yes, we try to make simulations using the big data set. And then actually we are already to do that, the implementation in our school, but because of Corona, so COVID-19, so we cannot do that in real time. So I try to make simulations by the data sets by using the Python, as I indicate in the parameters, yes, environments of the implementation.
Okay, thank you.
Thank you very much.
So,
Can you stop the screen sharing, please, Yoki?
okay, thank you.
Okay.
Is it present, one of the other authors?
This one? Stop.
Buksha Quasif? Bukra Quasif?
Maybe your microphone is off. You have to unmute yourself. Are you having technical problems? Maybe your microphone is off. Okay.
I'm sorry, what we are waiting for?
Sorry, what?
What we are waiting for? Who
The next presenter that is present but do not react. I don't know. So is present Dmitry
Nekrudov, it's me. I'm ready.
Can you start? Then we will see if the previous one will be able to recover.
Okay.
Please share your screen. Okay.
Is it fine?
Good. Okay.
Okay. I will try to be fast as possible. So, can we start?
Yes.
Yeah.
It's the name of my presentation, Fast Three-Dimensional Depth Velocity Model Building based on reflection real-time tomography and pre-stack time-migrated images. My name is Dmitry Nekrudov. So nowadays, depth imaging has become a necessary tool in the practice of seismic data processing. Pre-stack depth migration is especially important. The synonym of depth imaging is especially important in areas with complex geological condition in the presence of strong lateral velocity variations of geological properties. The reliability of depth images depends entirely on the adequacy of the depth velocity model of the medium. So here I put, just as example, I put here the final product of seismic processing in one of Siberian regions. It's geological map. Here we can see geological layers. So geologists can make a decision how this region is constructed. Jurassic layers, Paleozoic layers, and so on, some structures. To construct this map, they use depth image. This is a particular image of the Earth. To construct this image, we need to recover smooth velocity variation in the medium. Some example I put here. It is the most time-demanding part of seismic data processing. The final results depends on reliability of velocity model. So, standard velocity model building technique, velocity model, I mean this smooth distribution of some of seismic velocity properties. Standard technique, practical methods are very time-consuming. So we propose computationally efficient method to retrieve initial velocity model based on 3D reflection tomography. Methods oriented for depth velocity model building are based on the use of travel time of recorded seismic waves. Obtaining travel times of reflected waves in practice is very difficult because amount of seismic data acquired during modern seismic services is enormous. It is about tens and hundreds of terabytes. It's a first reason, and next reason is poor quality of seismic data. So this example of couple of seismograms, we can see nothing here. So it is almost impossible to pick travel times manually. So travel time tomography, any travel time tomographic approach based on travel time information can be decomposed into two main parts. First part is preparation of the input data. It means calculation of travel times residuals between observed and simulated seismic arrivals. And second step is inversion of travel time residuals. The main contribution of this topic is concentrated in the first part. So depth imaging is always performed at the later stage of seismic data processing workflow. Before depth imaging, time images of target area are constructed using so-called pre-stack time migration. I don't want to go into details. These images are used for preliminary interpretation. Main reflection horizons are usually picked in these images, time images, preliminary images. Having also some information, very preliminary information of velocities are constructed. So having this information, having these products of time processing, we propose an efficient algorithm for depth travel time tomography. So ingredients of our approach is number of time-migrated surfaces. Some examples is shown here, and cubes of stacking velocities. So we can convert this information into, using this information, we can approximate real travel times of real arrivals. So here some explanation of our method, but I'm not sure that I need to go into details. So finally, we come to standard travel time tomography. The input data is a travel time residuals. It is direct difference between observed travel time and calculated travel time. So this approach doesn't need manual picking. This procedure is fully automatic. So, and finally, we come to standard linear inverse problem. We have travel time residuals, we have linear operator, we have unknown correction to initial velocity model. For solution of linear inverse problem, we use so-called iterative reweighted least squares method. The engine of this method is well-known LSQR algorithm. It is important to highlight key features of system of linear equation arising in seismic tomography, a huge dimension of the system of equation. The dimension is 10 power 6 equations and more than 10 power 10 unknowns. Matrix is very sparse with relatively small numbers of non-zero elements. Problem is ill-posed in standard mathematical sense. So it demands using of preconditioning and regularization procedure. For real-world application, gigabytes of memory are needed to operate with such matrices, even taking into account their sparsity. So the implementation of 3D tomography should be initially focused on using high-performance computing system with distributed memory, means MPI implementation. So, and finally, I present real-life numerical example. The approach described above was applied for depth velocity model building for a certain area located in the Kara Sea, north of Russia. Narrow azimuth marine survey was performed in this area. The size of the area selected for numerical test was equal to 400 square kilometers. It's a small part of whole area. So here we can see initial velocity model and recovered velocity model. So you can see some updates. To make sure that this result is correct or satisfactory, we plot common image gathers in initial velocity model and recovered velocity model. In initial velocity model, we do not see.
3 minutes left.
Okay, I'm finalized. This final results, depth images of the area. So we can conclude that this approach is effective and works fine. We are happy at least. Thank you.
Okay. Okay. Thank you. Are there questions from the audience? Okay.
Okay. Thank you very much.
Okay. Bye. Thank you to you. Okay. Buchra disappeared. So Buchra solved the problems for Mamatoshi. Okay.
We can close the session.
So we can close the session because next there will be start the following session. Thanks to all attendees, also people here in presence. Thank you so much.
Okay, thank you very much.
Oh, it's here.
Who?
Bukhra?
Bukhra, are you here? No. Okay.
Bukhra, can you hear us? Bukhra? Okay.
Good morning to all of you. Welcome to PCIoT workshop. We talk together about privacy in the cloud edge IoT world. I'm glad to begin this workshop, and we have a little program change. There are two presenters who exceeded each other the presentation. The first presenter of this workshop is in person. Is Gizem Akman of University of Helsinki, and will present a paper namely Privacy Preserving Access for MSE Application by Gizem Akman, Philip Ginsburg, Valtteri Niemi. I'm sorry for the pronounce, but I don't know how well Finnish names may be pronounced. And I present Gizem Akman. Come here. Right.
Thank you. Okay.
You have 10 minutes. And 5 minutes for question and answer.
Okay, thank you. Hello, everyone. As I'm introduced, I'm Gizem Akman from University of Helsinki. I'm going to present our paper today. So to start with the what is MAC? Yeah, it's the multi-access edge computing. We are working on this because it's really going to be a key technology in 5G system, which is already in use for 4G as well. So it brings local servers to the edge of the mobile network. Like these local servers would be like Amazon AWS or Microsoft Azure, like as examples. This way, the application servers come closer to the users, so with the low latency, the quality of service increases a lot. So this is the schematic image of the system. You can see the user devices on the left. Here is the mobile network operator, which includes the base station, and the MAC host is deployed inside the mobile network operator. And the MAC applications are inside MAC host. These MAC applications are in communication with their main server, but mainly they are doing the job in the MAC host. And in our study, we are focusing on these three boxes. So they are like these Russian Matryoshka dolls. They are in each other, but independent entities after all. And first, we came up with a scenario and the system model. So here you can see the system model. We have this one user we call her Alice. Alice wants to use this blue MAC application. And the communication between them goes through these dashed lines over MNO and MAC host. So the deal here is that Alice does not want to reveal her identities or any data unless it's necessary to get the service. So for example, Alice might not want MNO to know which application she is using. Then we defined the adversary model for this system model. First one is for this MNO, MAC, and MAC application. They are honest but curious entities because they are doing a business, so they need to be trustful business to to continue their jobs. But yeah, they don't want to make a mistake to their customers, but still they want to learn as much as they can about like the habits of the user. Outsiders are Galileo adversary. They like Galileo adversary can see all the messages in the traffic, and like they can delete, rearrange, or just like inject messages. They can do everything to the traffic. And the other subscribers of MNO can be malicious adversary. Then we have these privacy notions. The first one is data confidentiality. It's mainly like preventing user data from the parties who do not need them for providing service. Similarly, identity confidentiality is protecting the user identities from those parties. Final, unlinkability. Yeah, it's the most complex one here. So it's for preventing to link to messages to the like same user or the same destination, or like having the same identifier, even the message is encrypted. And by considering the like adversary model and privacy notions and the system model, of course, we have listed following privacy requirements. Like I won't go through all of them now, but like it's basically for every entity in the system model, we have requirements for every privacy notion. For example, in these boxes, it's for data confidentiality for each like MNO, make, app, and outsiders. Then we came up with a like solution idea. Like in this picture, like it's like given that like connection between UE and MNO, between MNO and MEC, and between MEC and MEC application, there are secure connections already. But like here we want to protect the data from these entities themselves. So we would like to include 2 additional secure channels to the system. The first one is this outer channel between UE and MEC. The other one is an inner channel between UE and MEC application. There can be several protocols that can be used for these channels. One variant could be like TLS over UDP for outer channel and TLS over TCP for the inner channel. And finally, like I can conclude that our solution meets the privacy requirements pretty well. But the unlinkability requirements cannot fully fulfilled because like it's still possible to guess the application and the those habits through encrypted channels. So like we can not say it's fully fulfilled, but like it's not something like specific for the MEC technology or our system. So like the similar attacks against unlinkability can be in the like settings where MEC technology is not used. And this is all. Thank you for your attention.
Thank you very much. There are questions? Yes. There are some questions? Anyone has question? Discuss the discussion items? Okay. Thank you very much. And, okay, the next presenter is Islam Farmisdan. Farsi, madam.
Yes.
Excuse me for my not good pronunciation of your name.
No, it's good. It's good.
Okay, Islam, nice to meet you.
Okay, nice to meet you too. Thank you. So please let me share my slides.
Yeah.
Okay.
The paper which Islam presents is by Islam Farsimadan, Francesco Palmieri, Lelia Moradi, Diana Conte, and Beatrice Paternoster. And the title paper is Vehicle to Everything Communication Scenarios for Vehicular Ad Hoc Networking, an overview. Okay.
Okay.
You can start.
Okay, thank you. Could you see my slides?
Yes.
Yes.
Okay. Hello, everyone. I hope all of you are safe and well in this situation, and thank you for giving me this time to present our work. As you can see from the first slide of my presentation, our work is about vehicle to everything, or in short, V2x communication scenarios for vehicular ad hoc networking, or in short, VANET. This work is from me and my colleagues Francesco Palmieri, Leila Moradi, Professor Diana Conte, and Professor Beatrice Paternoster from University of Salerno. First of all, I want to say some motivation about our work. Why vehicular ad hoc networking? The use of normal traffic lights to control the flow of traffic on the road and at intersections is usually a challenging issue. It is difficult to manage traffic based on vehicle priority and road capacity when there is traffic congestion and there are many cars and vehicles in the roads. And also, many car companies, including BMW, Tesla, Hyundai, and Google, and other car companies, are designing self-driving and autonomous vehicles. These are some kind of motivations for having vehicular ad hoc networking. What is vehicular ad hoc network as a definition, I mean? Vehicular ad hoc network, or in short, VANET, is a particular type of mobile ad hoc networks, MANET, where the mobile nodes are vehicles traveling across the roads and streets. And also, other participants are roadside infrastructures and pedestrians. The main characteristics of these networks are the high mobility speed of the nodes and their positions constrained to the layout of the road and street. Actually, VANET provides innovative techniques for vehicular traffic control and management. Traffic, vehicular ad hoc networks are so related to virtual traffic light systems, or in short, VTL. Actually, for VANET, a considerable number of algorithms have been suggested. The virtual traffic system, or VTL, is one of the most important and famous traffic optimization methods for improving the movement of vehicles on the roads and intersections, so we can reduce congestion. Indeed, VTL and the smart traffic light system are alternatives that have been identified for the failing of the traditional traffic light system. We want to move from traditional traffic light system to a smart one. Many researchers are focusing on designing traffic lights using VTL in the context of smart cities, vehicle to everything communications, and IoT. So there are a lot of work that we can study, and we can go on in this kind of fields. But there are a lot of advantages of VTL. For the first one, VTL helps people to spend less time in traffic congestion, because time is so important in our life. So we can see the their time as an advantage VTL. Another advantage for VTL is reducing air and environmental pollution by spending less time in the, for example, in the intersections, in the road, and in general in congestions. Traffic causes stress, pollution, and road rage. VTL helps us to reduce them and improve the health and life quality. And also VTL accelerates large-scale deployment of autonomous vehicles, as we said in the first slide. And also VTL increases safety at intersections on highways and other road segments. VTL was presented for the first time in 2010. But what is the aim of VTL? Its aim is to alleviate traffic congestion by utilizing communications paradigms known as vehicle-to-everything technology, or V2x in short. But what is V2x? V2x is a new generation of information and communication technology aimed at connecting vehicles to everything surrounding them, same as other vehicles, infrastructures, pedestrians, and other things surrounding them. But based on the participants that communicate information directly, various forms of vehicle communication networks exist. But the most important are these four categories. Vehicle-to-vehicle or V2V networks are made up of mobile nodes that are actually moving vehicles that directly communicate with each other. Okay, the first one is vehicle-to-vehicle, which are communicating together. The second one is vehicle-to-pedestrian, or V2P in short. V2P network is built when vehicles interact and communicate with pedestrians which are close to them. The third one is vehicle-to-infrastructure, or V2I. V2I network is built when vehicles which are moving on the roads interact and communicate with road infrastructures, same as, for example, traffic lights. And the last one is about when the communication is between vehicle and data centers and or IT networks. The structure of the network is vehicle-to-network, or V2N in short. We can see these four categories of V2X here in this picture: V2V, V2P, V2N, and V2I, the main categories of V2X communications scenarios. But there are some applications actually for V2X. V2X enables the existence of different applications as a result of technological advancements in the fields of wireless sensing and networking. We can see here some of the applications of each scenario in this picture. As we said, there are four scenarios for V2X: V2I, V2P, V2V, and V2N. Here in this picture, we can see some of the applications of each one separately. But I want to go on to the next slide because I don't want to run out of the time.
Islam, excuse me.
Okay.
You have only 2 minutes to end the presentation.
I think, okay, there are a lot of things to say, but I will go on. Okay.
Thank you.
Okay, thank you. But the main important things about this, about V2X is applications and challenges. So I want to say these two maybe in this time that I have. In general, applications of V2X communication can be classified into three categories: safety applications, efficient applications, and information services applications. We can see here some of the examples of each of them. So because of the time, I will go forward. And in this table, we can see characteristics of V2X applications. Applications, channel models, benefits, latency, and packet loss rate. About challenges, the important part of V2x challenges is about reliability and latency challenges. For applications involving low latency and high reliability, network performance is critical. To gain crash avoidance and multi-user accessibility, DSRC employs carrier sense multiple access with collision avoidance to do this. But challenges related to security are divided in 4 categories: scalability of the network, communication latency, the main important one, dynamic topology of the network, and attack prevention. There are some other challenges related to security that I say here, and I will go on so fast because I don't have a lot of time. In the rest of the paper, we investigate and we explain each scenarios separately. Here, V2 vehicle to vehicle or V2V. Here, V2I. Here, V2N. And here, V2P. I don't have a lot of time to say everything. If you want, and if you're interested, you can study the paper, and we say everything there. So I go on. About the discussion of the paper, there are many efforts to design more efficient V2x communication approaches. In this work, some of them have been discussed based on their characteristics. The identified V2x scenarios and related key performance indicators are summarized and shown in the following table here. V2x category, which scenario is related to that, about its latency, data rate, and reliability for each one. Safety and traffic efficiency, autonomous operator driving, vehicular internet and infotainment, and remote diagnostic and management. About the conclusion of this work, we reviewed some of the most important algorithms about these 4 scenarios, and we discussed positive and negative points.
Okay, thank you, Eslam. There are questions for Eslam? Question, discussion issues? Okay, I have a question. Eslam, will present you some future works for this for the scenario you present, the future works, and in particular related to privacy issues. Eslam?
Eslam?
Eslam, are you here?
We cannot hear you.
Eslam? Okay. Donc, okay. If Eslam returns to us, okay. Eslam is with us. Eslam? You hear me?
Okay.
Okay.
Okay, Eslam. You heard my question? Future works for your landscape in this research topic.
Future works?
Yeah.
Yeah, the future works maybe is about the main important part of this work. I mean the challenges related to security. The security is so important in this kind of communication scenarios. So maybe if we can work on security issues, it will be a good work for the future.
Okay, some question? Okay. Thank you, Eslam.
Welcome. Thank you.
I think there is Giovanni Mazzeo. Giovanni?
Yeah. Hello, everybody. 1 second, I'm going to share my screen.
Okay. Nice to meet you, Giovanni.
Nice to meet you. Nice to meet you all. Can you see the screen?
Yes.
Yes.
Okay, perfect.
Okay.
So in this work, in this presentation, I'm going to present this paper, Privacy Preserving Credit Scoring via Functional Encryption. First of all, let me introduce the context quickly. The context is the context of the cryptocurrency financial market. This market is exploding. It has reached 1.8 trillion in 2021. And as a consequence, there is a strong trend in starting crypto loans that have seen a high increase in the last years. In this situation, since the crypto market is high volatile, there is the need for lenders to monitor the quality of their loans, and this happens via credit scoring. Credit scoring is basically an analysis that allows to determine the credit worthiness of a specific borrower. Why it is important for the privacy credit scoring? It is important because if an institution is able to steal, an attacker is able to steal confidential data taken by the user, he could get information on the client's wallet, on the human wallet information, and so predict the status of its credit. Or they could use API keys to, for example, steal money. So there are a number of keys that are used to get access to exchanges, such as Deribit and Binance. And these keys could be used to, for example, steal money. Which solutions do we have? Companies in this world are companies that want to provide the privacy-preserving computing, so the protection of data in use, typically use trusted execution environment, sometimes homomorphic encryption, and secure multi-party computation. These three are the widely accepted ones. There are other techniques. And maybe trusted execution environment is one of the most accepted. Each one of these has advantages and disadvantages. The trusted execution environment has the advantage that is quite simple, but has the disadvantage that you need to trust Intel, and the trusted execution environment is prone to bugs, and there are well-known attacks that have been discovered on trusted execution environments. Homomorphic encryption is very strong in terms of security, but it has the problem that there is no possibility with homomorphic encryption to get access to intermediate results in the hosting machines. So if I want to compare, for example, A and B, I cannot know, I can do this, but in order to know the result of the comparison between A and B, I need to, if I'm processing in the cloud, I need to ask to the client, to the user who is doing this processing, to decrypt that result. And this is quite tedious in terms of performance when you have conditional programs where there are several comparisons. Secure multi-party computation is also a good solution, but it has the problem that it requires that the client is online, that the user is online during the processing, and that is not always the case. So what we do, we leveraged an innovative approach, an innovative solution that is functional encryption. What is functional encryption? Functional encryption is an extension of homomorphic encryption that allows to solve the issue of homomorphic encryption that I was discussing before. So it allows to use specific keys that only permit the execution of intermediate processing. So with these keys, I can get the result of a specific computation, but I cannot get the confidential data, the input data. So I have, for example, A and B. I want to compare A and B with my special key. With this special key, I can decrypt the result of the comparison between A and B, but I cannot decrypt A or B. Okay, so that is the main advantage of functional encryption. The only disadvantage is that this technique is not mature enough. It is something that came around in the last years. And so even available libraries are still embryonic. So we made these. We used this technology in an infrastructure of the Xmargin company, which is a company that works in the field of crypto credit. And they used SGX, the trusted execution environment of Intel, that is SGX, and they wanted to increase the level of trust of their infrastructure. Our proposed solution was the following. So the idea is that we have the client generate the keys and encrypt the data with the functional encryption keys. He then provides these functional encryption keys, which are the keys for doing the computation. And we perform the computation in the untrusted environment, of Xmargin, using the functional encryption mechanism. We also performed an experimental evaluation. We evaluated the execution time of encryption and the computation plus decryption. So the decryption is quite small, and we computed both of them. The encryption, so experiments were conducted by increasing the number of users in the system and also varying the number of borrowers' attributes. So we are doing at the end, we're doing a machine learning algorithms, and this also depends, so that the performance also depends on the attributes that we select to classify the data. So the results are shown here. So with the encryption, we had quite good results. And with the decryption, instead, we had, with the computation, we had quite high computation times. So with 200, 400, 600 borrowers, the increase is linear. And with a number of attributes that is high, we reach quite a high computation time when there are 1,000 borrowers, for example, and we reach 200 seconds to compute the scores of these users. Obviously, it is important to notice that the number of attributes of 50 attributes is quite high. This is something that we selected to push to stress the algorithm. And typically, according also to what the company said, there are 20 attributes that are acceptable. So the future work in this case is to go for leveraging FPGA and also parallel architecture to improve the performance of the solution and make this solution usable by the company itself in production. Thank you.
Thank you, Giovanni. There are questions?
I hope I've been in the timing.
Okay.
In the correct timing.
Yes. You are in the correct time. There are questions for Giovanni? Okay, I have a question. Giovanni, do you think that you say that 50 attributes is a very high number? You are studied with the economist, financial expert for that number. I'm not an expert in financial, but I wanted to know the criteria to define 50 attributes. You are seen on bibliography, consulted an expert in financial loans, and
yeah, well, we had this collaboration. The work was made in collaboration with the Xmargin company, which works in the field of financial cryptocurrencies. So we discussed with them the reasonable numbers, and they said that a reasonable number to evaluate the performance of a credit was around 20 attributes, which are, I'm not going to describe which are these attributes because I also don't understand a lot of financial stuff. So they suggested this number, and we wanted to use also a higher number to stress above that value.
Thank you very much, Giovanni.
Thank you.
There are other questions? No? Okay, Giovanni, thank you very much.
Thank you.
Okay. There are the last presentation of this session. This is Fiammetta Marulli from University of Campania. This paper is also authored by mine. And the paper presented is risk analysis of a GDPR compliant deletion technique for consortium blockchains based on pseudonymization. Authored by Lelio Campanile, Pasquale Cantiello, Mauro Iacono, Fiammetta Marulli, and Michele Mastroianni.
Thank you.
Okay, go Fiammetta.
Okay. Thank you very much. Okay. Good morning to everybody, and we are just presenting this research, a little outline of our contribution, that are motivation research goals that stands on data deletion from a blockchain technology, blockchain-based system. A little I'll look at the background, that is just the GDPR requirements and blockchain's technology criticalities for supporting privacy preservation, and a case study that we propose with an application for Internet of Vehicles context. Okay, as research goals, we performed a preliminary analysis of current literature solution based on blockchain technologies in order to support individuals' privacy preservation in compliance with the European regulations for privacy preservation. And we furthermore proposed a case study by designing an implementation in the context of a traffic management system for the Internet of Vehicles, based on pseudonymization and cryptography solutions, and evaluating its in a preliminary way, its viability, its compliance to GDPR regulations, and the level of risks. As the background, we can consider the General Data Protection Regulation that was mandatory in the European Economic Area and the European Union from 2018. And it addresses mainly the transfer of personal data inside and outside the European Common and European Economic Area. And the GDPR primary aim is just to give control to individuals over personal data and to simplify the regulatory environment for international business by unifying regulation within and outside the Europe ground, Europe territory. And just some purposes of GDPR are just regulating, processing, and defining what we can mean for processing data, and what are personal data. Personal data means any information relating to an identified or identifiable natural person that are also called data subject. And for processing, we just mean any operation that can be performed over this personal data. And among this processing, the processing that can be performed on personal data, we just focus our attention on the adaptation or alteration and restriction and erasure and destruction of this data. And in particular, we will see them in the context of the blockchain technologies. Some key principles of the GDPR are just listed in the slide, and we can see that GDPR focus also on, among all these key principles, focus on one principle, that is the right to be forgotten. So the right to be forgotten, that is just to say the right to erasure, the right
right for a user to ask the erasure and the deletion of its personal data when these data are not more required to be stored and to be recorded in a system. So these rights are in relation to automated decision making and profiling. And in this case, in order to support the GDPR compliance and the GDPR compliance of systems, blockchain technology can support this process. But we have to consider that blockchains, even if it introduces some facilities to enable and to implement privacy and security, safety, and on the other side can introduce some criticalities that will be discussed in next slides. So the key characteristics, key features of blockchains are just summarized in this slide, that are decentralization of data, persistency and immutability, anonymity, and auditability. Some blockchains types, the most common are public blockchains, private blockchains, and consortium blockchains. And in particular, in this latter type, consensus process is usually used to control and is controlled by preselected nodes and managed jointly by institutions with multiple nodes. So consortium blockchains are particularly interesting as they can be considered as a middle case among the private and the public blockchains. And yet some advantages of blockchain solutions when they, in the security privacy perspective, can be considered de-hacking, that is virtually impossible. Blockchain-based systems are much less than prone to DDoS attack, and the blockchain may boost PKI. So these are some strength points of this technology. But some other issues of blockchains have to be faced, have to be considered. In particular, transparency, storage limitation, and right of subjects. And some of these key characteristics of a blockchain system based on blockchain are in contrast with privacy compliance. Okay, so what is our motivation? The motivation of the study: data erasure from a blockchain. In fact, data erasure is an aspect that represents an effective challenge to ensure GDPR compliance of blockchain systems. And in particular, we want to implement, we studied some mechanism for inserting and for providing a blockchain system with some advanced features for granting the right to be forgotten. And we also studied if introducing some important information can lead to a reduction of efficiency, and can introduce more risks in the safety and data breach for the data that have to be managed in the blockchain. The research approaches on blockchain data erasing are listed in this slide, but the most important and the one on which this work is focused is pseudonymization and cryptography approach. And in particular, we can see directly this. We know that pseudonymization is the technique in order to map effective real data on different data, in order that the identity of a person, of a subject, can't be recognized without an encryption or a decryption key. And in particular, we considered a case study in which we performed this experiment, and we considered. Sorry, but I have to be more faster in explaining this last part. And so, the right of data erasure was introduced into blockchain by introducing cryptography. So, if we consider that information that have to be recorded in a block inside a blockchain can be before encrypted, and that decryption information can be stored out of the block of the chain, we can just introduce a way to mitigating the right to be erased, to be forgotten, to implement the right to be forgotten also in a blockchain that is typically an immutable system. And in particular, we considered the case study of the Internet of Vehicles, and these are two use cases. In particular, between these two use cases, we are interested in on the case in which a user that is just involved in a smart road context need to be asked for a request for deletion of or updating his data. And in particular, this use case can be seen in this sequence diagram, in which a user asks for updating his data to a public registry, and there are some particular steps that can be performed in order to reverse the data, and in order to recover from the original data, and after for changing or asking for deleting. In particular, when a user asks for deleting its data, it can be she can ask to delete the key, the decryption key, and in this case the system is just not accessible, further accessible. And finally, we perform the risk assessment in order to evaluate if this kind of the introduction of cryptography and pseudonymization in the blockchain can impact the security of all the system. And the final, we adopted the CNIL-PA methodology for performing this risk assessment. And in particular, these are just in this slide we can see the feared events that are legitimate access to personal data, unwanted modification of personal data, and disappearance of personal data according to a likelihood and severity scale of risk. And finally, we, after performing some experiments that are just provided also in the full version of the paper, we just obtained this matrix in which we can see that finally that the most feared events, the three feared events covers also the green area. That is to say, that is the severity is significant, limited or negligible. And finally, we can just conclude that we focus on in this work on understanding the effects of one among the several techniques that literature offers to make blockchain compliant with the GDPR, and in particular pseudonymization cryptography approach. We also investigated the risk exposure of an example blockchain-based complex data management architecture that involves data that are need to be covered by GDPR, and in particular our interest was focused on how to permit to provision that are legally provided for by the regulation, but which cannot be carried out directly on a blockchain, and because of its immutable nature in a system that is devoted to Internet of Vehicle management. And as future works, we will include the analysis of other techniques and a comparison between the results, in order to evaluate which can be the best alternative with respect to risk minimization and to a general evaluation of for being more compliant to GDPR. So we are just looking for a trade-off among the right to be erased, the right to be forgotten, and for preserving the risk, to limit the risk of opening these possibilities. Thank you for your attention.
Thank you, Fiammetta. A bit of time.
Yeah, sorry for being a little bit out of time.
There are questions for Fiammetta?
Sorry for being just.
Okay. Okay. The first session of PCIoT workshop is finished, and I will remember you there are a second session in half an hour.
25 minutes.
25 minutes. Okay. See you later.
Thank you. Bukra, can you hear us?
Talk to you later.
Bukra? Can you hear us?
Recording is on.
Ragazzi, mi sono dimenticato, io rimanevo rincoglione dalla notte. Qualche giorno fa ho chiamato la collega dell'amministrazione, quella là che si occupa di
Gli adesivi, le etichette.
Etichette,
Fatto,
già date.
fatto. Grazie.
Yes. Okay. Okay. Good morning and welcome to this second session of the PCAE IoT workshop hosted by the ICCSA 2021 conference. If all the related presenters are ready and are online, we can just start with the first contribution that is presented by Dr. Pasquale Cantiello. And if Pasquale is online, okay, I can see you. Nice to see
Hi,
you,
Fametta.
Pasquale.
Can you hear me?
Yes, we can hear you. Okay, perfect. If you are ready, you can just start with the first contribution for today, for this second session.
Okay,
Thank you and enjoy it.
Okay, let me share my presentation.
Please remember that there are only 10 minutes.
10 minutes, okay, I will try to go faster than I can.
Okay, thank you.
Okay, share. Sharing.
It's the third button.
Yes, third button, but it can't do any action. Okay.
No?
No.
You are not able. Enable, yes, for
You can click on the third button for the.
Yes, I see the
button. Yes, with
the button. It talks.
Yeah.
It's the only button that it says share your screen, but
It's not working.
Not working. Okay.
Okay. You can send to me your presentation, and I will share it for you.
Okay.
But we can move on to the next one.
Yes.
And then we can go with
okay.
Pasquale, and I send my email to you. Okay.
Okay.
In private.
Okay, I think now it's
working.
Yes, it's working.
Okay, perfect.
Okay.
Okay.
Can you see the presentation?
Yes.
Yes. Okay. Okay, good morning to you. I am Pasquale Cantiello, and I'm working now for Istituto Nazionale di Geofisica e Vulcanologia, and this work has been made with my colleagues of University della Campania. It's a work about GDPR, and the main objects of this work are to help organization to demonstrate the compliance of their process, their way or their work to the regulation. We all know that GDPR address needs for social network-based society, but it has some side effect of especially for small enterprises. They are working hard to address such this requirement imposed by GDPR. As an example, GDPR imposed for new processes, for new personal information treatment that must be conducted a DP and data privacy impact assessment. That is a hard work to conduct. In this work, we have the main objective of helping especially small and medium enterprises to address this duty. And we have started by analyzing the GDPR, the regulation entirely, and approach it as a conceptual map. I will show now the representation, and starting from the representation, we have decided to map the articles of the regulation with standard security controls. In this way, enterprise can map their process to the regulation and get the security control they should apply on their process to verify and demonstrate the compliance. Okay, in the GDPR, we have identified 8 main concepts. We can see on the left side of this picture, the GDPR represents as an association of these contexts. We can start for personal data, which is the main data involved in regulated by the GDPR. We can see the actors involved, general obligation that a processor or controller should apply, the processing of all the treatment that are made on data, a consent which is a special part of the GDPR, and some security and personal data concerns, the part of the rights of the data subject, and the tool that who is obliged to adhere to the GDPR should be used and approved. For each of these 8 concepts, we have exposed some sub-concept. I will try to go faster. Just as an example for personal data, we and see that personal data can be divided into 3 main types: intimate data, such as career, birthplace, contacts, or genetic data, that's biometric features, or some other healthy, some other data. Okay, let's go again. For actors, we have identified all the actors involved in the GDPR, like the controller, processor, who is the recipient as external processor, who is the data protection officer, and who is a data subject. For the obligation, in the same way, I go away. The consent is, we have identified what are the main aspects involved in the consent definition, what is a consent, what is how it must be presented and asked to the person whose data has been processed, the conditions who must be applied, and information that must be followed. Processing, type of processing, I go faster on this. How security of personal data must be assured with the data processing and security, or data protection impact assessment, which is the hard process we can try to do easily with this aspect. Okay. This is the whole map representation of the GDPR, and after starting that, we have thought about the complexity of demonstration of compliance to the GDPR. GDPR has an approach that it's particular, since it does not give constraints to enterprises. It does not imposes the regulation, but and so does not give a unique solution to implement them. So data controller has the freedom to process the user data, but he must provide that his processing is made properly. In our work, we have tried to build the security policies that, starting from process, could help the data processor to give the set of standard security controls that must be applied and verified in order to demonstrate the compliance. We have chosen the NIST security control framework, which is now at its fifth release. These are standard security control framework divided into almost 20 categories, which is summarized here. Starting from access control, planning, program management, personal security. Okay. Our process, our work, is this. We, starting from all the GDPR articles, for each of article, we have stated if it's a technical or organization, if it imposes a technical organization measure to prove it. For all article, we have selected all privacy-related NIST control, technical and organization one, and for each of them, we have checked against all the GDPR articles of the same type, finding if this control can be used to grant compliance to regulation or article. If this control it's able to grant compliance, we describe the limits of this compliance, what the control can provide and what cannot, and outline if it control relates to system that organization means. And we have outlined all the enhancement with that control, since the NIST framework has enhancement for each control to further refine the process. After the analysis of all related controls with their enhancement, we have restarted the process for all security controls that are listed in related controls of the framework. And for each of them, if this is relevant, for this we can start the process again and apply also the steps in before. If it's an improvement, we add the ID of the control, description of the control. In the end, we analyze all security controls, not analyze, and if needed, apply the process described in step 2.
Okay. Sorry, only 2 minutes remain. Okay.
Okay, go. And the end, we have done a full review of the framework. Our output is a NIST control mapping with the GDPR. So we have article on the first column, the number of the article, the title, and the control, the NIST related. So this is an example of the full table we have produced after this work. So we see that for Article 7, that is conditions for consent, it's a technical measure description, and we have from the fifth columns and so on, the NIST control related to this, with limits, technical measure, and enhancement related. Okay, I will go fast. After this representation, this mapping, we won't try to extend the methodology to full automated process countermeasure selection. So generating a report that outlines how this countermeasure addresses GDPR requirements and integrate these maybe with some tools that can be analyze directly the data protection impact analysis as prescribed. I was fast enough.
Okay, that's perfect. Thank you. Are there some questions? Any questions for Dr. Cantillo for his contribution? No, it seems that it's all clear. Thank you, Pasquale.
Thank you, Fiammetta, to you and you.
You're welcome, and we can just go on with the second contribution for today.
Professor, can you stop the screen sharing, please?
Yes.
Professor Cantello? Okay, thanks.
Okay, thank you. Okay. The second contribution is entitled Toward the Design of Blood Donation Management by Blockchain Technologies. Are there some of the authors or is here with us some authors, also the orator or the presenter for this contribution? Is there someone for this contribution? Oh.
Yes.
Yes, perfect. Yeah.
Well,
Okay, you are thank you. Oh, nice to meet you. You're welcome.
Okay. Are you having some technical issues? Hello?
I'm trying to share my screen.
Yes.
Oh, so what's your name? Sorry.
My name is Hong.
What? Which one? Son? Oh, okay.
Okay, the second one. Yes. Perfect.
Yep. Did you see that?
Yes.
Yeah.
Okay. Will we start?
Yes. Yes, we can see your presentation.
Okay. So, good morning. My name is Song. And also come here with me today is Song and Nga. We are here this morning to talk to you about management issue interacting with blockchain platform, which one focus on healthcare system that we feel is of great importance. Our objective not only try to persuade you to take a stand on this issue, but we also would like to present some sides of the issue to you in order to contribute our effort to improve the blood donation management system, which has a great impact on healthcare system. We want to take this opportunity to thank you for allowing us to come before the ICCSA for this blood donation management issue interpretations. Our topic today is Tower Design Blood Donation Management by Blockchain Technologies. So from now on, we will follow this outline structure into 6 main parts to be sure that we can clarify our proposed solutions. As you can see here from part 1 with introduction to part 6 from the slide. So the first one, I will tell you why we choose this topic and its importance in human life. As you know, blockchain technologies is increasingly known as cryptocurrency, NFT, in research, and especially in medical industry. One issue to consider in this is blood donations. Accompanying this is the issue of clarifying on the detail of blood donations in the supply chain system for everyone involved. In addition, there are 2 important issues that cannot be ignored. One blood is some donors do not know about their health situations. This reflects in blood quality, and one more is information flow from the place of blood collections to the place of consumption or destruction is unclear. That's what's in bias. And finally, we decide to research and come up with a solution to that problem. Blood donation management, which is based on blockchain technologies. And now about our methodology. With the depth of knowledge that has been devoted to this field, as well as a number of equally improved innovations for the issue, such as minimizing cost and risk, handling urgent requests from blood unit in a web, controlling location, allocation, inventory, and delivery, supporting for decision-making in the blood supply chains using both geographic information system and data mining technique, as well as improving information sharing in blood supply chains. So, from those influential research, the applications of blockchain technology in this field is indisputable, with some aspects highlights such as improving blood supply chains, visibility, and streamlining workflow, tracking and timestamp visibility, which prevent the production of counterfeit medicines. The solution we propose can ensure transparency of blood information management by using real-time blockchain. This system can deal with emergency when the blood demand suddenly increase in specific area. Now I will clarify our design of blood donations. You can follow our picture for easier understanding. With the design of blood donation management, data for each blood sample donated by a volunteer will be stored at a medical facility. This blood data is only accessible by facility medical staff. The blood sample will be shipped to the other medical facility or hospital after the test is complete. After changing the storage locations, data for every blood sample will be updated with the respective medical facility. Now implemented. This is the process of system implementations. I will help you to explain one by one. So with the first one, we will record the day and time information in the transactions. After 1 day in the system, the retention period of entire blood access is reduced by 1 day. The separate ID of blood type include day and time, allowing user to see the retention period of blood donations. And the movement state is defined to indicate whether the blood is currently moving or within the organ. The blood ownership information is defined. Managing the blood process includes transportation, which is defined as one of the important steps in the whole process. The information of delivery company is also recorded to serve the purpose of verifications. Information recorded in the system include ID company, ID delivery, name of delivery man, age, phone number, address of delivery man also. And information of patient who received donation blood is recorded to the system under the structure, as you can see at the left half of the slide. And the last one, patient and medical personal information is also created and stored to determine which unit of blood is determined whether healthcare staff can access the blood data. Information recorded in system consists of 6 components such as patient ID, blood sample, name, age, address, and medical status. Now, algorithm. In this paper, we implement 2 main algorithms. The first one is to store the blood sample of donor. And the second one, to transport the blood sample from donation place to medical center. Now, the last part, security, privacy discussions, and conclusions. This picture shows the problem approach. To improve the security and privacy issue in the blockchain-based blood donation system, we will exploit attribute-based access control to manage the access control process. The main benefit of this model is only the authorized user can access the release data. Query rewriting can apply for complex contexts where the release data can be set to multiple users. Some approaches split the original policies into sub-policies to ensure that the data is only accessed via permission, even the party in the same transactions. For flexible aspect, we should embed the blood donations management system in the larger environment while combining with the other supply chains, as well as connecting with the other smart things. In this research, we try to accomplish 2 goals: to increase the visibility of blood security information to ensure the quality of blood for both receiver and donor. Furthermore, by resolving problems that may arise in medical institutions and with medical staff in systems, which prevent forgery and information tampering, will make the blood management operation more transparent. And for the future research, we consider the proposed design cost and network configurations. Also view additional information such as block size and hacking preventions. As we bring our blood donation issue interpretation to a close, we once again thank you for allowing us to be here this morning, and hope that this activity can give you a much clearer understanding of this blood donation management. From now, our team will answer if you have any questions. Thank you.
Okay. Thank you. Thank you for your contribution. It was very interesting application of blockchains to a very critical problem that is just a blood donation supply chain. And I have a question for you. Have you considered in next advances in next proceedings of your work if the problem of deletion of data, as we also study the problem of deletion of data, that is to say when we are just talking about the blood, that is just a matter, an item that has to be considered as it is for its freshness, and that has to be consumed in in particular times. So have you considered these possibilities, this extension of this problem, just for introducing, for changing the data and for updating data and erasing data when where the blood is not fresh and can't be used yet if it has not to be provided to someone that needs it. Thank you.
Sir, are you there? Can you help me to answer these questions?
Yes, no. I'd like to know if you have considered this opportunity.
Sorry?
In your proceeding work.
Sorry. Hello, can you hear me?
Yes. Now we can hear you. Yes.
Okay, perfect. So sorry because I hear your question very well, but the connection in my location is not really good. So, okay, thank you very much for your question. Your question focused on how can I store all the information, includes the place and the time for when some volunteer donates the blood for the medical rights, something like this.
Yes.
Okay, thank you very much for your question. The first one's on the information, not only the types of the blood or the key information of the volunteer who donate the blood for the medical stuff. We includes everything in the one. How can I say, one start of the one transaction, and all the information encrypted. And when the stop transfer this information to the endpoint, I mean the patient, only the key information, some kinds of the time, the place, or the kinds of the blood can show to the patient, and the other information still keep in encrypt, and that's the reason why on the privacy information keeps secure in this way.
Okay, perfect. Thank you. Thank you very
Thank
much.
you very much.
Thank you very
Thank
much.
you for the question.
Thank you. Okay, we can just go on with the third contribution for today. That is, this contribution is entitled "Usable Privacy in Location-Based Services: The Need for a Regulatory Framework." And I think that we have two presenters that are Dr. Bjorn Beringer and Per Hufhaus. Sorry for my bad pronunciation. Okay. I think that you are here because we are just looking. Yes, we can see Bjorn. Are you here?
Yes, thank you very much.
Thank you. You're welcome.
I can hear you. I hope that you can hear us and you can see my shared screen.
Yes, you. Okay. Yes, we can see it.
Right now, you can see the presentation, right?
Yes, we can see it. Yes, perfect.
Perfect. So we're ready. If you're ready, we can start.
Yes, you can. We are ready. You can just start. Thank you.
Thank you very much for having us. My name is Björn Beringer. I am from the Westfalia University of Applied Science. Next to me is my colleague Per Hufhaus. We are colleagues, and we are presenting our study entitled "Usable Privacy in Location-Based Services: The Need for a Regulatory Framework." This study originated from my master thesis and is an example how students' work is connected to our research in our communication management department. I would hand over to my colleague Per who would introduce you to the topic.
Right, the study was part of an overarching project called Location-Based Services in Regional Media Communication. The target is to identify opportunities and risks of LBS, so location-based services, for regional media communication, so as to derive recommendations for action with concrete success factors and evaluation methods for the digital transformation of regional media communication. This has already covered some technology acceptance studies that we've conducted, some quantitative user surveys, also qualitative stuff like focus group discussions, huge LBS market exploration, literature reviews, Delphi study that we've just finished and is also meant to cover some prototyping aspects in the near future. And among all these studies that we've conducted, the key question, which factors influence usability in designing and using location-based services, was already always apparent. So that's what our current study focuses on. And with that being said, our methodology, from a methodological perspective, our study included qualitative, or was based on qualitative interviews with 22 international and multidisciplinary participants with scientific and entrepreneurial backgrounds. The interviews lasted 45 to 60 minutes each and were recorded, transcribed, and then coded with making use of Meiring's qualitative content analysis. The guidelines for the interviews covered questions concerning the meaning of location, security risks for location-based services, usability aspects, areas of implementation, which is what this study takes a specific look at. And lastly, also the future expectations in this field. And based on the qualitative content analysis, the categories were derived from the semantic context, resulting in a system of several overarching dimensions with various categories and subcategories. As we said, we focus on the barriers. With that, I hand over to Björn.
Thank you very much. And I will introduce you to the barriers of implementation, which are, I can hear my voice in the back. I will just continue. I will present you the findings. On the right, you can see a graphic which shows the category usable data security in relation to usable LBS usage. And there it becomes very apparent that there's a need for a framework. And this framework includes socio-ethical factors, regulatory factors, and also technological factors. Our participants mentioned that, for example, participant number 10 said, I do think it comes back to creating a framework, a code that can help guide the way in which the LBS application is developed. The next point is competing factors, also on the provider side and also on the user side. On the one hand, it occurs because if you talk to developers, they absolutely hate it. They hate the UPS related effort, which mean that there's a lot of work to do to implement these user privacy and security principles and factors in the developing process of location-based services. Also, security risks became apparent, especially on the provider side and also on the user side. Especially there, I will continue with this one later, but the main topic of some factors are the business models that are based on the gathering of personal data, especially when you look on the right on business interests of third parties, because they're not so interested into creating LBS more usable. They want to gain as much data as possible. On the user side, also anti-pattern and the lack of knowledge were the barriers related to UPS and LBS. Yes. To follow up with findings, I will sum up 5 statements which we created out our study. The first one, the successful integration of UPS factors into LBS seems to require a regulatory framework, as I mentioned before, covering the entire value chain of location-based services. This includes also all stakeholders at governmental, economic, and civil society levels. The second one, embedding UPS factors into LBS applications increases the ability to control data security regulations. As a result, more responsibility and expertise on behalf of the user is mandatory. Third one, by involving the user in the configuration of user-friendly systems, the danger of information overload arises. In this scenario, user may favor previously known systems that they perceive to be easier to use. And the fourth one, user-friendly data security in LBS applications is primarily prevented by anti-patterns. The resulting obstacles may primarily affect the field of location-based advertising. And the last one, number 5, more data security for the user in LBS applications contradicts the business interest of third-party providers who are mainly interested in collecting data, collecting as much data as possible. Here we have the findings and conclusions. I think my colleague Per-Ole will continue on this one, right?
Unmute your microphone.
Yeah, you can have to speak.
Sorry, my microphone. Can you hear me now?
Yes.
Okay, sorry, it somehow deactivated itself. Several findings and conclusions can be drawn. Collectively, the participants endorsed the call for more regulation and guidance by designing a regulatory framework covering socio-ethical, regulatory, and technological factors. And several barriers were also identified to interfere with user-friendly data security and LBS usage, such as additional expenses on the provider side, such as costs for personnel and development. And according to some participants, also user-friendly data security might not be compatible with a commercially oriented collection of user data. Lastly, also commercially oriented actors expect regulatory restrictions, such as governments incentivizing user-friendly data security.
To continue with that, potential factors having a positive influence on the data management. For example, the increased control over one's own data. Everybody wants to control their own data, this obviously, but the possibility of data minimization is also very, very nice. The increasing customization or the control options, like increased control of our own data, can overwhelm the end user. And the extensive legal regulations, such as the GDPR, it's quite complex. We heard it today, but it's worth it to investigate more in this direction. But I will continue with that one later. Everybody know the privacy by design principles, and they are also connected to the GDPR. And this is one of the main topics which are very important for the UPS and also in relation to LBS. To sum it up, UPS will guide, is connected to the increased app usage, and this one have a will continue in a value chain, especially for providers. Yes. We will now look to the future research. I think we're nearly at the end of our presentation. It's worth it to design a kind of a framework and to implement this under the overwhelming GDPR, and to identify or investigate the relationship between all the stakeholders among the value chain of location-based services. It is useful to prove to investigate and compare possible correlations between user-friendly data security and location-based services in different national jurisdictions, for example, in Asia or in the United States, etc. And that's it.
So here you can see some references. Thank you very much for your attention. This was our presentation about usable privacy in location-based services and the need for a regulatory framework. You can see some contact info. And if you have any questions left, feel free to ask now.
Thank you very much.
Thank you.
Okay. Thank you to you, to all of you. And if the other participants have some questions for our presenters, are there any questions? Okay, if there are no other questions, I can only say something about your work, because I was just a reviewer, or I just performed the review of your paper, and I just found it very interesting, because it just highlights a problem that basically affects the privacy solutions. That is to say, the user awareness about the privacy, what we share, what we agree when we allow to applications, to smart application and location-based system to track us and to collect our data. because some very most of times, as I can just explain my user experience, we are more focused on data breach or data violation, but we do not pay more the needed attention to what we are just sharing according in our awareness. Okay, so probably your work is important in order to highlight this problem and in order to focus attention also on user awareness on what we are just sharing and what we are agree to share according to privacy management and privacy and security problems. And this can be also done by performing, just by implementing more usable application and more usable way by which we can best and better understand what we are just sharing with the application and with third parties that are just collecting this data that can use them for application, for marketing, or for any other commercial other purposes. Okay. It was very interesting for me. Thank you for your contribution.
Thank you very much.
Thank you for the feedback.
Thank you.
Thank you. Okay.
I will end this shared screen now.
Okay, perfect. I think that there are no other questions for our doctors, and we can just go on with the last presentation, the last contribution for today, that is entitled Dataset Anonymization for Machine Learning in IFP Case Study. And I can see just Dr. Carlo Sangetz that is online. And Carlo, you are welcome. And when you are ready, you can just share your screen and you can just start your presentation as soon as you are ready to start. And we'll just use it.
You need to unmute your microphone.
Okay.
You're still muted.
Carlo, the microphone, you have to switch on your microphone.
Okay, sorry. Good morning.
Good morning, you're welcome.
Okay.
Nice to meet you.
Okay. Can you hear me? Yeah?
Yes, we can see your presentation. You can just hear you.
Oh, okay, thank you. Okay. Good morning. My name is Carlo Sangetz, and I'm a software engineer based on Naples, Italy. And I'm going to show you a comparative study of forecasting performance using raw data and anonymized data. Before I start, I would like to thank Lelio Campanile, Fiammetta Marulli, Fabio Forgione, and Gianfranco Palmero. So, okay, this is the agenda of my talk. After a very short introduction, I will show you the goal of our work, the case study of our work. I will talk to you about the data sets we used in order to do our experiment. I mean the raw data set with a lot of sensitive information and anonymous data set. And last but not least, I will talk to you about the conclusions and some future works. So let's move on. Introduction. Sometimes, especially when we talk about data mining application, machine learning application, one of the biggest issue is how to preserve the privacy of data. Sometimes it's not possible to share data to an external third party because of the sensitive data information in the data set. And we also know that there are a lot of methods in order to help us to preserve privacy. There are a lot of algorithms to do the randomization or perturbation of the data set. But what about performance? What about the success rate of prediction? we worked a lot with people of internet service providers. We know that internet service provider technical supports needs personal data to predict potential anomalies. When I say personal data, I mean IP address of a user, MAC address of a user device, sometimes location of the house of the customer, and so and so. Our goal was to find a solution to classify a given condition of a user device by using only data with no personal information inside it. The question was, is there a good classification algorithm for our purposes? Which classification algorithm that works well on anonymous data? And what about our case study? Flyber, our case study is based on Flyber. Flyber is a tiny wireless internet service provider based on Italy. The staff of Flyber works hard in order to offer the best connection to customer. And because the technology is a wireless over open bands, the quality of the connection depends on radio interference. And as a consequence of this, Flyber uses a system in order to check in real time the health status of the customer premise equipment. When I say customer premise equipment, I mean a sort of a radio device in the house of a customer. And sometimes, because the connection is not so good, a customer of Flyber opens an issue, and as a consequence of the opening of the issue, the staff of Flyber saves a lot of information according to the issue: name, identity of a customer, location of house, IP address, MAC address, and so and so. So our case study includes the architecture of Flyber. The architecture of Flyber includes 10 sites for the spread of a signal, about 2,000 radio, about 2,000 user devices, customer relationship management software, network management system software, and a lot of data. Well, our goal was to find a solution. The goal of the staff of Flyber is to do a sort of practice in order to predict the anomalies, in order to offer the best quality of connection. In the first part of our work, we classify the records according to conditions: with the reporting by customer, I said before, opening the issue, and without reporting by the customer. Then we train the model able to classify a given condition on the customer premise equipment by using, in this time, personal data, no anonymization, raw dataset. Then we tried to transform the data in using different techniques in order to do anonymization of the personal data. And then we trained a model able to classify a given condition on the customer premise equipment using at this time only data sensitive information. The problem is now, what about performance? What about the success rate in terms of prediction of anomalies? So just two words about the data. Time frame was from December 2020 to March 2021. About 70 reports. Each report includes daily data incoming from about 600 antennas. Antennas is the customer equipment, premise equipment. about 1,600 issues from customer, and about 40,000 samples. A lot of data, a lot of sensitive information inside the data set. In the first part of our work, of our experiments, we tried with several algorithms. I mean, logistic regression and random forest. We had the best performance, we had the best success rate in terms of prediction of anomalies used by using random forest. And then we tried to do the transformation of a data set, because we cannot use the raw data set because the sensitive data inside it. So we tried different techniques. As you can see in this slide, we used attribute subtraction, character masking, pseudo-anonymization by hash, generalization, and so and so. We did the transformation using a pretty simple Python code. And but what about results? The results from attribute suppression were not so good. In this case, we have simply deleted the columns that include the personal data from the data set. So code was pretty simple. But because the success rate was not so good for the purposes of Flyber stuff, we tried other techniques. And we tried character masking. Also, in this case, the algorithm is simple. But and now we had a good success rate in terms of prediction. But the problem was, the critical issue here was the time that was lost in transforming personal data via code. And then we changed and we tried the hash function. So in this case, we simply applied hash function to the personal data. In this case, results from pseudo-anonymization was good. But we had the worst performance in terms of time, because because in this case we waste a lot of time to transform personal data via code. This algorithm is not suitable for the use of the Flyber stuff. Then we tried another algorithm. In this case, as you can see this slide, we also have good prediction, good success rate in terms of prediction. Also in this case, the Python code was and is very, very, very simple. But we had to, in this case, two questions to investigate. Two issues. The first, the number of features has changed. Indeed, the non-anonymous dataset, I mean the raw dataset, included about 1,000 characteristics, while the final dataset had 300 characteristics. And also in this case, we had the time issue. As you can see, I put the result in this slide. As you can see, the best result in terms of prediction of anomalies we had by using pseudo-anonymization. And the worst prediction we had here. But because we needed a solution, a next real-time solution in order to do the prediction of anomalies, no one of these techniques can be used in order to do the proactive maintenance. As a consequence of this, first we saw that when we work on a real world application like fiber use case study, you see the impact of the anonymization, and in our case the impact was real. So we tried in the next future we will try different algorithm, different technique in order to improve the quality of anonymization. And because we had a issue related to time, we are working hard in order to introduce a more complex software and hardware architecture. In this case, we are working to distribute the computational load on multiple computational devices. In fact, now we had only a single ARM Linux box that runs machine learning code. In next future, we are working in order to have 2 or more of these computational device. And my talk is over. Thanks for your attention. Do I need to mute my microphone?
No. You can have your switch on. We're just asking for. Are there some questions? Any questions for Dr. Sankets about this contribution? Okay, I think that there are no other questions because the problem is clear, and it's very important for us that studying machine learning and anonymization techniques and which are the main issues for this problem. So if there are no questions for him, I can declare that this session is ended, is finished, and I want to thank you all the participants and all the organization. I want to thank Dr. Sarah Kuku for her precious technical support in this session, and I hope that you enjoyed the session. And thank you, and enjoy the rest of the conference and the rest of the day. Thank you very much.
Thank you. Bye. Bye,
Carlo. Thank you.
Thank you. Bye.
Thank you to all of you.
Thank you.
Bye. See you next time, next year in the next edition of this conference. Thank you.